So we first need to establish where the axis is, where the resistance and where the force are. So how do we know where those places are? What are those definitions? Where's the axis?
Kind of rotation.
Okay. Which is generally what part of the body?
The joint.
The joint. So when we're talking about the axis, we're looking at the joint, and it's directly through the center of the joint. So even though like your electron process is like all a part of that joint, your joint is through the middle portion of your elbow. It's not like necessarily specifically your electron process.
So that's the joint that's like being affected, or the one that would be moving?
It's the one that's moving that is being affected by the resistance. Generally. Unless you're on like a fixed surface, like for example with a push-up. Yeah, with your push-up, it's at your wrist if you're looking at just your arms. But if you're looking at your whole body, it's at your toes.
Okay.
So if it's to a fixed surface, it's generally the joint that's basically on the surface. Okay. So that's the axis. What's the force? How do you find the force?
Two-step process.
It is a two-step process.
So it's for insertion. Yeah.
So you have to figure out what the muscle group is involved by using the two-step process and then figuring out where it inserts. Okay.
Did we figure out what the axis was, or are we just naming them?
I was just defining them real quick.
Okay.
And then the resistance, where is that? What is that?
Center of gravity at the location of the external resistance.
Good. So it is the center of gravity. So in this case, it's just where the resistance is being applied. So in this case, I'll just kind of show you. So the ankle would be the axis, because that's the point of rotation. That's what's going to move with this force. So that's your axis. Then you have your resistance, which is the force that's pulling right there at the toes. And by the two-step process, we know that the motion that the resistance is going to cause is plantar flexion. Therefore, your dorsiflexors are the involved muscle group, which cross your ankle anteriorly and will attach about here. So that's where the force is. So we have the axis, force, and resistance. So with that order of things, what class system is this? Third. Good.
Because the axis is in the middle.
The axis is closer to the force, and it's on the other side of the force comparatively to the resistance. Because with the first, second, and third class, so for first class, we have a force, we have an axis, and then we have resistance. Second class, we have the force and the resistance, but we have the axis over here. For third class, we have the force and resistance, but the axis is over here. And how, an easy way to remember this is that if you're flying first class planes, you go to a faraway place because you're rich. Then, if you have two dogs, they bark at each other and go arf. And then for the AFR, that's like Africa, which pretty much all the countries in Africa are third world countries. So that helps. Just something to think about.
So you put the force though, like where the dorsiflexors would insert?
Mm-hmm.
Okay.
Yep.
Where it would insert would be.
Yep. Okay, so this is a third class lever system. Does that make sense?
Mm-hmm.
Okay. Reagan, was there anything else that you wanted to go over? Was
With
there anything
those?
specific? To add?
I just kind of wanted to go over, let's see. The angle of resistance.
Angle of resistance?
Yeah.
Okay. So now, let's do the same thing, only someone's applying a force in this direction.
Wait, what was the force on the other one? Where was the arrow?
The force was, it was a weight that was down here.
Oh,
and it was
okay,
a
yeah,
strap
that's right.
to the foot. So it was pulling in that direction. So in this case, where's your axis?
Same, your ankle.
Good. Right through the middle. Okay.
Why isn't it your toes? Like what? 'Cause aren't your toes pivoting too? Or no, it's just my ankle.
It's mostly where most of the force is being directed.
Okay.
Because like it'll pull on your toes, but your toes don't really move
Okay.
much. Like that's not where the muscles are being attached to directly move.
Okay.
Okay. Where's the resistance?
Where they're pushing on the foot.
Good. That's the resistance of the axis. Where is the force? What muscle group is working?
Plantar flexors.
Good. Where do those insert?
Don't know.
In between the resistance and axis.
Nope, they actually do not. Because if you have your foot, you have your toes, right? And then your metatarsals, and then your tarsals, one of which is your calcaneus. And right here is where your tibia and fibula cross the ankle joint. So your ankle joint is right here. And your soleus, which is one of your plantar flexors, attaches to your calcaneus.
So what's at your calcaneus?
Hmm?
The force is going to be at your calcaneus?
Correct. So your force is actually going to be on this side of your axis.
So it's far. So it's first class?
Mhm.
Yep. Does that make sense? Okay. Sweet. Okay. So then, let's see, when it comes to where's the axis? This is a dumbbell pullover, so it's like this, and you're going like this.
So it's at your elbow.
Correct? Where's the resistance?
Down here.
Okay, it is closer to there.
Isn't it? Oh, never mind.
Okay,
So is the resistance where you think of center of gravity?
correct, yep. That it is.
Would that be the middle of your forearm then?
So it's not directly in the middle, because if it was directly in the middle, then that means that this side would balance this side. But because the weight is going to be pulling down, that's going to have a more of a force, so it's going to slightly pull the center of gravity this way. So that's the resistance.
So explain that one more time. Why it's just to the right?
Okay, so if we have a huge box, a weight,
Okay.
I'm going to draw it in the same direction as this. So we have this weight, right? And we also have the weight of our arm, which is just a middle weight.
Okay.
Okay? With this, if we have the axis in the middle here, this is definitely going to drop, right? If you're thinking like a balance, this is going to be a lot heavier than this side.
Okay.
So in order to make it balanced, which is the center of gravity, you would have to bring it closer to the heavier weight.
Oh, okay. That makes sense.
Okay. Okay. So where is the force?
This one I thought was weird because he was talking about how it's where the tricep inserts or something. So the tricep or something inserts, but it was like the same spot as the axis.
Okay. So that's when it gets down to the nitty gritty. So it's just like tiny, there's a tiny difference. And that's why I was talking about how the axis is going through the middle of your joint. It's not necessarily the olecranon, sorry, I say that weird, process. It's through the middle of your elbow.
So then your triceps would.
So your
insert
triceps
there.
would insert about right there. So it is like basically the elbow, generally speaking. But if you look at the specific little part, that's where the force is.
Okay.
So what class system is this?
First.
Good. Okay.
And that was when the involved muscle group, that's going to be my elbow. We're doing this motion, right? So it'll be my elbow extensors, right?
Correct.
And so that's why it's, whatever. Okay.
That's why it's your tricep. Okay. That's your extensor, your elbow extensor. Okay. So now, you have a question?
No, I was just on a different type of one. That's all.
Okay. Okay. This one is an external rotation. So you're here, you're going here. Okay. Where's your axis? Well, actually, let's not do axis first. Let's look at resistance.
It's going down here, right? Ish.
So the resistance, yeah.
Can I cause you to go down?
Yeah, so the resistance, so you're looking at the center of gravity when it comes to the resistance. So in relation to this, is this a big box and a little box, or like?
That's gonna be the big box.
Good, okay. And if there is a significant difference, like in the ratio, then it's not, it depends on the ratio of how it pulls the center of gravity. Because if you have, let's see. Okay, so if we have the center of gravity, we're thinking, initially you look at the center of the picture, right?
Mm-hmm.
And so, but this weight,
It's too big. It's like the big box, right?
yes, it is the big box. How do I want to think about this? So I actually think of where the weight directly is, because that's usually the center of gravity. But depending on how big of a difference the weight of this section is compared to the other side, that will determine how far the center of gravity is pulled. And because this is a very small ratio compared to a whole weight, it's pretty much going to be along that line. Does that make sense?
Kind of.
So in this case, we have the big box,
Yeah.
little box, and because this is so small, the axis is going to be